Okay, number 2 here is calculator inactive. This time they don't give us the function. They give it to us arranged in a table, and it's kind of a funky looking table here. We've got specific values at -2, -1, 1, and 3, and then we're given information about the intervals in between. So this will allow us to make some more definite conclusions. We've seen some tables like this before, but we've never seen them with those intervals. And so I've tried to warn you against making some of these generic comments about, oh, well, it's increasing on this interval because f prime is negative here and negative here. Well, what about what happens in between those two values? We don't know because they don't give us that information. But here they do give us that information. Okay. For example, between -2 and -1, we know that the derivative is always negative. So we can say that the function is decreasing from -2 to -1, and we know that it changes at -1. Well, it doesn't change, actually. It's still negative on the other side of -1, but that is a possible critical point. Anyways, that's just a little bit about the table. Let's get into the actual problem here. It does give us information about two different functions. We've got function f and function g, and then both of their derivatives. It says find the x-coordinate of each relative minimum of f on the interval from -2 to 3. So minimums happen where the derivative changes from negative to positive. So let's look at our derivative function here of f. We're just concerned about f. And we need to find where it changes from negative to positive. So from negative to positive, that happens here at x equals 1. So part A, x equals 1 is the only relative minimum of f on -2 to 3, because that is the only place where f prime changes from negative to positive. So you get 1 point for that. You have to have the correct answer, x equals 1, and you have to have the justification. Okay, let's look at part B. Part B says explain why there must be a value c between -1 and 1 such that f double prime of c equals 0. So anytime we're talking about c values, we should be thinking one of our theorems. Okay, intermediate value theorem. Well, that talks about the value of the function, so that doesn't apply. Then we've got the mean value theorem. Okay, remember the mean value theorem says that the slope of the tangent line is equal to the slope of the secant line. So we're talking about the second derivative equaling 0. So that would be like the slope of the tangent line. Well, f double prime would be tangent to f prime. So let's set this up for the mean value theorem. Okay, the slope of the secant line, so f prime of -1 minus f prime of +1 over -1 minus 1. So f prime of -1 is 0. F prime of +1 is 0. So we've got 0 minus 0 over -2, which equals 0. Therefore, since f prime is differentiable, they told us that. Remember, we do, anytime we use these theorems, we have to have differentiability and continuity. Since it's differentiable, then f prime is continuous. And by the mean value theorem, don't abbreviate it. There is at least one value of C on -1 is less than X, which is less than 1, for which F double prime of C equals 0. Okay, so since the slope of the secant line, so to speak, and in this case the secant line involves the derivative, is equal to 0, then we can say that somewhere on that interval the derivative of that, aka the second derivative, will equal 0. All right, so you get 1 point for this part, f prime of 1 minus f prime of -1 equaling 0, and you get 1 point for your explanation using the mean value theorem. Okay, part C, the function h is defined by the natural log of f of x. Find h prime of 3, show the computations that lead to your answer. Love these. So h of prime is equal to the natural log of f of x. So we want the derivative. Chain rule, derivative of the natural log is 1 over the function that was inside the natural log times the derivative of the function that was inside the natural log. So h prime of 3 is equal to 1 over f of 3, or let's just go ahead and put this as one fraction here. The derivative part's on top. So f prime of 3 from the table is 1/2. F of 3 from the table is 7, so that's 1/2 times 1 over 7. So this is equal to 1 over 14. You get 2 points for your derivative. I'm assuming that would be 1 point for the 1 over and 1 point for the multiplying by the f prime of x, and then you get 1 point for the answer of 1 over 14. So we've awarded 6 points so far. We've got 3 points left for the last part, so let's check out part D. Part D says evaluate the integral from -2 to 3 of f prime of g of x times g prime of x dx. Okay, so don't get super overwhelmed by this because it looks crazy, but let's think about what we're looking at. I see derivatives inside of an integral. Okay, you see derivatives inside of an integral. So let's just think simple. Okay, if I ask you what's the antiderivative of f prime of x, your answer is f of x. Okay, so we're looking at the antiderivative of a derivative. So that's going to give us the original. Well, what is that the derivative of? That's a chain rule derivative. So we are looking at the integral from -2 to 3. I'm just recopying it so I can look at it clearly here. G prime of x dx. That is equal to f of g of x. Okay? If we take the derivative of that, we're going to end up with f prime of g of x times g prime of x. That's what's inside our integral here. But whenever we do this and there are numbers involved, we have to evaluate it at the numbers. So this is f of g of 3 minus f of g of -2. So g of 3 from the table is 1. G of -2 from the table is -1. And then f of 1 is 2, f of -1 is 8. So our final answer is -6. So you get 2 points for applying the fundamental theorem of calculus. So essentially for identifying this and then plugging in your intervals, or excuse me, plugging in your limits, and then you get 1 point for the final answer. So, moral of the story, don't be intimidated by something that looks like that. Think of a simpler case, figure out what the answer would be, and then apply that to what you're looking at, okay?